Well, that means that HE is between the other two. HE is
Okay.
in the middle. Does that look okay to you?
Um, I think so. I mean, would the answer not be HI, or is it like asking
Well, yeah,
what's
because be, because I think what is not supposed to be there is this one I've sort of drawn from the like this is not array. Let me get rid of this. It's just like your base because 180 degrees is going this direction. So if we were to draw it sort of more simplistically, like imagine that's H, that's I, H E, H O. And I think that's more clear about which one is in the middle, which is H E.
okay? All right.
All right, so that answers that question. Now this other picture is good for finding angle measures. So before we even jump to that other question, though, if the whole thing is 180 and this is 81 degrees, what is the missing angle here?
99.
99. So if we were to add that in, I'm going to do that here in a different color. This one is 99 degrees. What about the one between these two? What's that angle measure? We know the whole thing is 81 and this is 18.
63.
Yes. Now, I'm not saying we need those, but we might. Uh, you will be finding angle measures at some point in this class. So just maybe we're foreshadowing that a bit. Um, so question 5 says, name the and find the measure of the three angles formed by the rays. So they're looking for, I'll help here, the measure of angle IHE, measure of angle EHO, and then the whole thing, the measure of angle IHHO. So it's part, part, and whole, part, and whole. And I can't get the whole, I can't get all of that to fit on the screen, but hopefully your drawing you can see it's we've already got two of those. Three. So the IHE is 63 degrees, EHO is 99 degrees.
All right.
So the whole thing, add them together, what would that add up to?
Um, 162.
Yes. All right. Okay. Now your book is very heavy into like it's like which did you use for exercise 4? So like what's your justification for which one is in the middle? It's either 1, 2, or 3.
Uh, will that just be the betweenness of rays?
So it's either the definition of betweenness of rays or the betweenness of rays theorem. So what's the difference between those? What's the definition of rays? Say they're at the is what does that say at the top there of that page?
Rays between two other in the same half rotation if and only if its coordinate is between their coordinates.
Okay, so that sounds more like which one is between. The betweenness of Ray's theorem that you were referring to there, notice in red, I'll snip that in, it's got an angle sum. This looks more like it applies to what we just did over here, where you're adding up the angles.
Okay.
So the answer number 7, it's this one. Number 6 is the definition of betweenness.
Okay, so I didn't write down 4 and 5 because it said to use a protractor and I don't have one right now.
Okay. I mean, your diagram, it can be like this as long as it's reasonable. But your instructor may say otherwise. But of course, you get the notes at the end too. So don't take too much stock and don't overcomplicate it. Sometimes we want this to be more than it needs to be. Um, that's everything for that page. So if you're ready, I'm ready to move on to the next page.
Okay, well, let me just write this down then.
Okay, sounds good.
All right. Mm,
Okay. Um, gonna move. You said 16. Add up.
16 to 20.
Okay. All right. All right. So uh, the point of this problem is it says the apparent size of an angle depends on your point of view. Um, this is a piece of wood, and if you've ever looked at a piece of wood, you actually know the answer to 17, which is the angles. What are the actual angles in a piece of wood, if you're familiar with that?
Like, how many angles are there?
Well,
Or,
like what is the angle measure of the wood? Like it comes pre-cut, like the trees don't grow the
oh,
wood like this, right?
90.
Like, yeah, they're all 90-degree angles. Like every single angle you see in this picture is 90 degrees. But some of them don't look 90 degrees, do they?
Hmm.
And it depends on the perspective you have. Now, one of the questions I have, because I don't know this book, I've never seen this book before. It's like, do they also want you to include the ones that you can't see, or just the ones that are visual? Um, it's like if you look on the front, and sometimes it's good to draw the front. The front, there are four angles. One, two, three, four angles in the front. The top has how many angles again? Five, six, seven, and eight. And then the right side has how many angles? Again, four, right? 9, 10, 11, and 12. So what you're seeing, hopefully, is that each face has four angles.
Hmm.
So there's like 12 angles you can see, but the board has more than 12 angles.
Yeah.
But sometimes it's important to go off of what you see. Like if you're jumping into water and you don't know how deep it is, that could be dangerous. You'd like to see how deep it is. Sometimes it doesn't matter. Um, so I don't know how to answer this. There's 12 that you can see, but there's 24 total angles in the drawing.
Yeah.
Okay. The so that's this. Now, assuming that is an ordinary board, meaning like one you'd go to the store and get, how many of them are right angles? Well, all of them. They're all right angles. Do you have any pieces of wood in your garage or outside that you could go confirm this with if you needed to later?
I don't, but
Okay.
I,
You get it. You get it.
yeah, seen, or I mean, like I've built things with that. So,
It doesn't even have to be wood. I mean, just go to like a your cereal box. Put the cereal box down on the side. It's the same idea.
hmm.
Okay. Now, to do 18 and 19, we got to go back to the picture. Grab the picture one more time, and then we're going to answer these questions about, which ones are acute and which ones are obtuse. So 18 is acute. Um, so I'm gonna say that the front ones, none of the front ones look acute, but maybe there's ones on the side that look acute or the top. And you have to use three letters for the angle.
Okay.
So can you give me one acute angle that you see?
Um, so like as if this wasn't just an ordinary board.
Yeah, they're saying just like
Okay.
like imagine like it actually looks, like this.
Okay. EDC.
EDC, good. I would agree with that. Any others that stand out to you as likely being acute, or not likely, being looking like they're acute?
Um, GFC.
Okay, not going to argue with that. What do you think about CBG?
CBG. Yeah, that too.
Okay. And what about the one in the back here, this one, DEF? What do you think of that one? I don't have an opinion.
Um, for me, that one looks more obtuse.
Okay, so let's throw it in the obtuse one. DEF. Okay. Any other obtuse angles that you see?
PCF
You said
and
DCF.
mhm,
Yes, I agree.
and BCF.
Okay.
Also FGB.
Okay. All right. So I feel like we're missing one because the four front ones we were agreeing all are 90. So we're missing one more. So I know we've got EDT, DEF is down here. Do we have EFC? Where would you put EFC? Maybe that's 90.
EFC.
Yeah.
Um, it looks like a 90-degree angle to me.
Okay. That's fine. All right. These are very abstract questions. Like there's more algebraic geometry. These are more pure geometry. All right. Do you know much about birds flying in this orientation?
Yeah, I mean, I know about it, but like, I mean, I don't study it.
So what I believe to be true, and you can tell me if you know differently, is the obviously the first one is helping all the others, and then they go back. So like then this one in the back here, he comes up or she, and they replace that one, he comes down or she comes down, and they just do this like to fly. Like it's kind of a neat thing. Um, from the people I know that ride bicycles, they actually do the same thing. They have a leader and then he comes back down, 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 and then they have someone come back up. I don't know. I couldn't believe that bicyclist is, but that's what they do.
Hmm.
So, you know, I don't know. But is it possible to tell from the photograph what type of angle the birds are flying? So I think the real issue here is we're talking about something in 3 dimensions and we're putting it on 2 dimensions.
Mhm.
There's always a projection. So it works out really well when you saw in the previous problem when the 2 dimensional projection is perfect, like the front face. It's not very good when it's far away. So the question here is like you're like if you want to visualize like you're taking this picture of of the of the birds and you're like looking up and they're kind of at an angle. The question is how much distortion is there or uncertainty? And I would say there's a lot.
Mhm.
Uh, did you do any art classes where you had to draw like a street view? You had you had a building.
Um, I don't think so.
Okay. But you can kind of visualize like there's a street, there's people walking on the street, but the houses get smaller, but they're not really getting smaller. And then the street's actually getting narrower. It's kind of extreme, but that's maybe you'll see that the next time you look at something. I don't know. I
Yeah.
think this is more of a this is more of a like how well can you justify your answer? Like, I think both are correct. Like maybe you can sit there and be like, yeah, it's 90 degrees. Or you're like, nope, no way to know. It comes down to like, or 45 degrees, maybe. I don't know, whatever you like. It comes down to like, how well can you justify your answer? Kind of like the legal system, who's a better, who can better explain their position.
Yeah.
Or you got to the internet and you look for like, you know, for how do birds fly? Like, what's the angle in a V?
Hmm.
Which I'm going to if you don't want to, because I think it's I'm kind of curious. It says it's 45 degrees.
Yeah, that looks about right. I don't know actually.
So if you had a your compass protractor, you could put it on here and you could measure the angle, except
Hmm.
not that way. Boy, that's terrible. That is really bad. You would not do that. You would put that there and you would measure that angle. And you would get probably more than 45 degrees, but not like you wouldn't you'd probably actually get closer to 75 degrees.
Hmm.
Depending on what you're doing, maybe that's close enough. All right. Any questions, thoughts on that?
Mm-mm.
Okay. Do you want us to like preview the next section of the book? Maybe your upcoming homework assignments. We can look at those.
Sorry, 1 second.
Sure.
Okay, sorry.
So we've got some time left. Just want to best use it. Happy to, preview some future stuff for you, or I can grab some problems. I've been working with other students kind of in this part of the course.
Okay. Um, it looks like the next section in the book is bisecting.
Okay. You want to send over some pictures? Do you want me just to kind of do some things on bisecting?
The thing is that I don't have like a ruler and protractor and compass, and at least I
Okay.
don't think so. Like right now, I mean, I left it at my locker.
Okay. That's fine. I'm not gonna grade you on not having your stuff for class. Okay. So like you're literally gonna like I guess what I'm hearing is you're going to get problems where you're going to bisect an angle. Is that right?
Mhm.
Okay. So I can show you a few examples, but we're going to need to we're going to, you're going to get more out of it if you had a compass and a protractor, but we can go through a few things here. You know how to copy an angle?
What's that? I'm not sure. I mean, maybe it'd be familiar.
Okay, so like let's just say your teacher will put something like this on a tester because they'll say copy angle ABC, and you're like, okay. So the first thing you do is you grab your ruler and you draw something like that. And that's supposed to represent, you know, this down here. You put a point for B. It doesn't matter where it goes. Okay. And then you stick your compass pointing in there and you swing an arc here at C. And so you get, all right, I got C. Yeah, I got C. Okay. Now, the next thing you do is you swing an arc that hits both of these.
Hmm.
Okay. Actually, I'm sorry. You don't need to do that. You can, but you don't need to do that. You swing an arc there. So you do the same thing here. You swing this arc and you hit there. Then you stick the pointy end in there, swing an arc up here, and now you've got this connecting point. And now you use your ruler to connect these points, and then you grab your protractor and you measure. You're like, okay, how well did I do? So I did terrible. This is, 28 degrees and this is 34 degrees, something like, because I'm freehanding it. But that's the first thing that you have to know how to copy an angle. So hopefully you guys get to do that, figure that out. Now, once you've copied an angle or once you know how to copy an angle, the next thing they talk about is bisecting an angle. It's just all about knowing the steps. Okay. So we'll call that point P. So to bisect an angle, you first swing an arc like this. Okay. Call that uh, A, and then that, B or whatever. Doesn't really matter. Then you go to either A or B, it doesn't matter which, stick the sharp end in there, and you swing an arc kind of up here. Now, the thing about this is that it's got to be more than halfway. Okay. And then you go up to A, or if you were at A and you go down to B and you swing the same arc, and you create this intersection point, call that M, grab your ruler, connect those 2 points. And then these angles should be congruent. Should be, right? Famous last words. So that's where you grab your protractor and you measure. And hopefully they're close enough. Like this is where it's easy to grade. It's like, all right, if they're within a degree, that's an A. If they're within 2 degrees, that's a B. You're truly graded on how accurate that you can do it.
Yeah.
Okay. Now you might be like, well, why would I ever want to do this? Well, you'll be given problems like this where there's a triangle and you end up bisecting the angle, bisecting the angle, bisecting the angle, and they all meet in one point, which is called something. You'll notice like religious symbols have this kind of, you'll start noticing some of this stuff now in movies and things. So that's one application of it. Another is like if they give you a quadrilateral and you bisect it like that, you'll find some things out about these shapes, things like that. So it's really important to be able to bisect an angle.
Hmm.
Okay. Now they usually pair it with something else. Like they'll teach you how to make a perpendicular bisector. So a perpendicular bisector means that these are now 90-degree angles. That's another type of construction that you'll do. If you bisect this angle, what is the angle measured?
Um, 90 degrees.
You're bisecting it though. You're cutting it in half. In half.
Oh, 45.
Yes. So sometimes they give you questions um, where they ask you to try to bisect an angle to make a 45-degree angle. They also they also might ask you to make a 135-degree angle, which is really a 90-degree angle plus a 45-degree angle. So notice that like the red here would be 135 degrees.
Hmm.
And I have no idea what your instructor uh, wants you to do this, but these are possibilities. Um, Sometimes they want you to make a 60-degree angle. You might be like, how would you make a 60-degree angle? Well, you have to recognize that it comes from an equilateral triangle. An equilateral triangle is all sides the same, all angles the same, right?
Hmm.
You know that from previous courses. So that's how you make a 60-degree angle. You somehow make an equilateral triangle, which, we'll see. We'll see if you have to do that. I have no idea. Um, but then they could ask you to make a 30-degree angle. Let's say you knew how to make an equilateral triangle to make a 60-degree angle. How would you make a 30-degree angle? Answer is bisecting the angle.
Hmm.
Now, I haven't seen this in a long time, but like I could imagine a question where they wanted you to make a 75-degree angle, which is a 45-degree plus a 30-degree, which means constructing some sort of equilateral triangle, then constructing a perpendicular bisector and bisecting that, bisecting the and then copying those angles to make it. Like you're not supposed to not use the tracker. And you might say, why? I don't know. That's just that's the course you're in. Okay. Is that good for now?
Hmm.
Okay. Let's do a couple of these problems. We're working with another student. She's in a course like yours. It's more traditional. She doesn't like it very much, which I get, sir. It's like learning to use a typewriter. Right. So this is kind of like what we're doing here. All right. All right. Given angle DAY, day, and YAK yak are a linear pair. Do you remember what a linear pair is from earlier?
Um, um, I don't know. Maybe it look familiar.
Okay, a linear pair is a straight line with like something coming out of it. So the straight line is 180 degrees.
Hmm.
So like, see how these share letter A? I know they share Y too, but A is the middle letter. That's the vertex. So like BAY, YAK. So what do you know about a linear pair? I've kind of hinted at it over here on the right.
It makes 180 degrees.
Yes, but what specifically makes 180 degrees?
Two angles.
The measure of those angles. The measure of angle DAY plus the measure of angle YAK equals 180 degrees. So notice that that's different than saying that they make a linear pair. So one is talking about like, I don't know, it's like a visual, and the other is like numeric or like an equation. So in this course, like you can't just say the measure of day plus the measure of yak equals 180. You have to first say that they're a linear pair. And since they're a linear pair, that means their angle measures add up to 180.
Mm-hmm.
Is that okay?
Yeah.
All right. Now the justification, this is the hardest part for most students. You typically always start out with it's the definition of, and then you fill in the blank. And the fill in the blank comes from, well, whatever it is that you're talking about. In this case, it's a linear pair.
Mm-hmm.
Okay. Uh, let's look at another one here. Don't want that. Come on. Okay. I don't know if you guys see that on that side or not. Okay. All right. We're given this figure. We got MUT, TUS. These are angles. MUT is angle 6. TUS is 5. This is like going backwards from the one we just did. What do we know about MUT, angle MUT, and angle TUS? What do they make?
A linear pair.
Yes, this is the whole point of this course. If I tell you they're a linear pair, that means they add up to 180. If they fall on a straight line like this, they are a linear pair.
Mm-hmm.
All right. Now, the other thing we could do, because we actually don't know for sure that, and not saying this wrong, it's just a bad question. We're not sure that this is a straight line. Like it didn't say it is. It kind of looks like it is. It probably is. So here's the other thing we could say. Angle MUT plus angle TUS equals angle MUS.
Mm-hmm.
Because part plus the part equals the whole.
Yeah.
So it kind of depends on what you're doing in the proof, which one is correct, which one is not correct. All right, let's try a basic one here. More basic one here. You prefer cats or dogs or something else?
That's fine.
All right. So this one's given angle cat and angle rat are vertical angles. Okay. What can you conclude about vertical angles?
Uh, they're vertical.
Okay. Let's try your RAP. So vertical angles are congruent. Are congruent. Okay. So what does that mean about these two angles? They are
Congruent.
congruent. Yes. So angle CAT is congruent to angle RAP. One leads to the other. Like you can't go to this step here without saying this step here. Which maybe, I don't know. Maybe you're okay with that. Like most students aren't. They're like, why do I have to justify it? It's like, because that's what you have to do in the class. I don't. Just the rules. Justification. Definition of what? What is the definition of here?
Vertical angles.
Yes, right? Very good. All right, let's try one more here. Close out. All right, I'm going to give you the conclusion. Tell me what I'm trying. Give me your own words for what I'm trying to say here.
Um, line EF plus line FG equals line EG.
Okay. Can you give me a physical example of what that's referred to? Something in real life.
Uh, oh, what do you mean?
I always think of sandwiches. You ever had a sandwich cut in half?
Mhm.
It's like, all right, that part of the sandwich plus that part of the sandwich equals the whole sandwich. Part plus part equals whole.
Okay.
All right, we're gonna stop